Hello everyone and welcome back. Today we will observe the tokenization of lexical analyzer. So let's get to learning. Coming to the outcome of this session, here we will learn how to count the number of tokens in a given code segment. Now before getting straight to tokenization, let's revise a bit about the tokens. In the previous session itself, we learned that tokens can broadly be classified into 7 different categories. These are identifiers, operators, constants, keywords, literals, punctuators, and special characters. Let's now consider the source code which we have been observing from the very first session. Today, we will enlist all the different tokens of this code, and along with that, we will keep a count of the tokens that we encounter. Initially, I'm setting the count as 0. Let's begin. Now the very first token that we encounter is int. Int is actually a keyword in C. So now the count becomes 1. The next token is main. Now this one is the name of this function. So simply it's an identifier. Basically, using it, we can identify this function. Let's increment the count. It is 2 now. Coming to the next one, it is the left parenthesis, and it falls under the token category of punctuators. So this will increase our count to 3. Next up is the right parenthesis, and this one is also a punctuator. So now the count is 4. Next we encounter the left curly brace, which indicates the starting of the block of main's definition. This is another punctuator. So with this one, the count becomes 5. Then again we encounter the keyword int. So this will up our count by 1, making it 6. Next, we have the variable x. So it will fall under the category of identifiers, and now our count becomes 7. Next in line is the comma. Well, this is also a token which falls under the punctuator category. So the count is 8 now. We have encountered 8 tokens so far. Coming to the next token, it is the variable a. So it will fall under the identifier category, and the count will be now 9. Now we have the equals operator, that is the assignment operator. So naturally, it is an operator token. So now our count is 10. Then we have the value 2. Since it is a fixed value, it will fall under the constant token category. Count is now 11. Next is again the comma punctuator. It's already been enlisted once. However, it will increase our count and make it 12. Every occurrence of each token will increase the count no matter how many times we come across that. Always remember, the lexical analyzer scans the entire source code line by line. Next, we have the variable b. It is an identifier. So the count now becomes 13. Then again we have come across the assignment operator. So the count is again up by 1, making it 14. Now the fixed value 3 will fall under the constant token category. Count will now be 15. Again the comma punctuator will increase the count to 16. Next up is the variable c. It also is an identifier like main, x, a, and b. So the count is now 17. The assignment operator will also increase the count to 18. Now the identifier c is being assigned with the fixed value 5. 5 will be enlisted in the constant token category. With this, the count becomes 19. Now this semicolon is the statement terminator. This one falls under the punctuated token category. So now the count of tokens becomes 20. Coming to this statement, here we encounter the identifier x again. So count will now be 21. The assignment operator will also increase our token count to 22. Next up is the variable a. So count becomes 23. Now this plus operator is the addition operator. So naturally it will fall under the operator token category. With this, the count increases to 24. Then we again have the variable b. It has already been enlisted earlier, so our token count will now become 25. Next, we encounter the multiplication operator, and it will also naturally fall under the operator token category, increasing the token count to 26. Thereafter, the variable c will again raise the count to 27, and with this semicolon punctuator, the count of tokens by the end of this statement will become 28. So far, we have encountered 28 tokens. Coming to the next statement, here the printf is actually the name of this function. So basically it is an identifier, and with this the token count becomes 29. Next, we again encounter the punctuator left parenthesis. However, this time it is pertaining to the printf function. So our token count will now be 30. Coming to the next token, here the entire string, that is starting from this double quotes till the ending of double quotes, this entire string is a single token. It falls under the literal category. So the count becomes 31. Now this entire literal token is one of the arguments of the printf function. For separating arguments from one another, the punctuated token comma is used. So the token count now becomes 32. Next argument of the printf function is x. The value held by it will be reflected in the string in place of the format specifier %d. Since it prints decimal values, that is why the letter d is used here. Anyway, the identifier x will increase the token count to 33. Then we encounter the punctuated token right parenthesis, which specifies the end of the argument list of the printf function. So this will raise the count to 34. Now once again we have come across the punctuator semicolon. So let's increment the token count. Now the token count is 35. In the next statement, we encountered the keyword return. Let's enlist it. With this, the count becomes 36. Thereafter, we have 0 because the main function has the return type as int. If you remember, in the session introduction, I told you that under error-free circumstances, the main is supposed to return 0 only. Now since 0 is again a fixed value, therefore it will fall under the constant token category, increasing the token count to 37. Next, we encountered the punctuator semicolon again, so our count will become 38 now. Finally, the right curly brace signifies the end of the main function's definition. Now this is another punctuator which increases our token count to 39. So in this entire piece of code, we have 39 tokens, from which some are keywords, some are identifiers, some punctuators. We also have encountered some operators, a few constants, and one string literal. Do remember, every occurrence of the tokens is counted by the lexical analyzer, no matter how many times it has appeared in the pure high-level language code. So in today's session, we have learned how to count the number of tokens in a given code segment. Alright people, that will be all for this session. In the next session, we will solve some numerical problems on lexical analyzer. So I hope to see you in the next one. Thank you all for watching.